Today we're talking about Descartes Rule and Conjugate Rule theorem. You'll be able to find complex zeros and write polynomial functions with those complex zeros. So first, Descartes Rule is if you have a polynomial function with real coefficients, okay, so basically what we've been dealing with the last couple of days, then you have two different pieces of information, or at least be able to find it. You'll be able to find the number of positive real zeros of the function is equal to the number of variations in signs of the function, or less by some even number, and the number of negative real zeros of the function is the same as the number of variations of signs of f of negative x, or less than that number by some even number.
Okay, what's the difference between f and f of x?
Same thing. F and f of x are the same thing, so you have your function basically. F and f of x are the same thing. So basically you can figure out your number of positive real zeros and your number of negative real zeros by basically looking at this changing in your signs of. So, alright, so basically you can determine if you have positive or negative real zeros by looking at how the signs change in the function, okay? However many times it changes will tell you how many positive real zeros you have, okay? Possible. When you do f of negative x, you should have seen this before. We've seen this before.
It's the inverse.
Not the inverse.
No.
To find the neither.
This is what we use to find it whether it's even, odd, or neither, okay? If you plug in negative x and simplify, and then look at that function and the number of times the signs change from positive to negative, that will tell you how many negative real zeros you have, okay? Possible. So, I've written out a list of steps that are on your paper that you would follow to determine this information, okay? And we're going to go step by step. So let's look at the first example, okay? So, we have f of x equals all that information. Real quick with your arms, show me what this polynomial would look like if we were to graph it. Very good. It would look like this because my degree is even or odd. And a is positive or negative. Very good. So it should look like that. A good review of the last section. So it says look at the polynomial and its signs. Draw lines underneath the polynomial to highlight where the signs change from positive to negative or negative to positive from one term to the next. So this one's positive, this one is
Positive.
so there's no change, this one is
Positive.
no change, this one is
Positive.
no change, this one is
Negative.
I have a change. Okay? Then I go from this term to this term. Is there a change?
Yes.
So I got another one. Then I go from this term to this term. Is there a change?
No.
Is there a change?
No.
So right here basically tells us because there were two sign changes, that means I have a total of two possible positive real zeros.
Why would it be positive?
Because it's the original function, x is positive. When we do negative x, then we'll figure out how many negative real zeros we have. So step 2 says count how many little lines, how many signs change you identify. This is the maximum possible number of positive zeros. Step 3 says to count down by 2s to find the possible number of positive real zeros. So if I count down by 2s, my next number would be what?
0.
So I can either have 2 or 0 positive real zeros. Now positive, that means, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay?
So you couldn't have one.
No.
Okay.
Alright? So now, step 4 says, next look at f of negative x. And I even put in parentheses, plug in negative x for all the x's of the original function. Just in case you've got it. Just in case. So, we should be used to this. When we plug in a negative x for every single x, and now simplify. When you raise a negative x to an odd power Are you gonna get a positive x or a negative x?
Negative x.
So, because this negative x is raised to the 7th power, that means it's gonna be negative x to the 7th, which makes this very first term a
Negative 4x to the 7th.
negative 4x to the 7th. You don't lose the exponent on the variable, okay? What about when I raise a negative x to an even power? It's gonna end up being positive. So this becomes a positive 3x to the 6th. What about here? Negative x to the 5th becomes a negative x to the 5th. When I cube a negative x, this is going to end up, before I incorporate the minus, this is going to end up being a what? It's going to be a negative x to the 3rd. Two negatives make a what?
Positive.
So this is a plus x.
Why did you skip to a plus?
I did skip to x to the 4th. Oops, I missed that. Add in to negative x to the 4th. I did forget that one, I'm sorry. Sorry, so that'd be plus 2x to the 4th, and then it would be plus x to the 3rd. When I square it, negative x, it becomes a
Plus 9x squared.
9x squared, then
Minus x.
minus x, then
Plus 1.
plus 1. So there's my function, f of negative x. And now step 5 says count the number of sign changes, just like I did in steps 1 and 2. This will tell me the maximum possible number of negative zeros. So, from the first term to the second, do I change?
Yes.
From the second to the third, do I change? Do I change?
Yes.
Do I change?
No.
Do I change?
No.
Do I change?
Yes.
Do I change? Yes. So I went from negative to positive. So how many sign changes is that? So I have a maximum possible 5 negative zeros. And now step 6 says again count down by 2s to find the possible number of negative real zeros. So what's 2 down from 5?
3.
And what's 2 down from 3?
1.
So I can either have 1 negative 0, 3 negative zeros, or 5 negative zeros. And all of these are real zeros. Now if I were to graph this, it would show me exactly how many positive and negative ones I have. And it will fall into one of these. I'll either have 2 positive or no positive, 1 negative, 3 negative, or 5 negative. It would have to be either a combination of these or one of the other. Simple enough, right? Yes. So let's do this one. Here's my original function. How many sign changes do I have? 3. I have a change here, I have a change here, and I have a change here. So because I have 3 sign changes, that means I have a maximum number of 3 positive real zeros. Or I could have 1. To find my negative zeros, I plug in negative x. Did I miss any? Nope. And simplify. This becomes 2x to the 4th. Minus 3x to the 3rd, because when I raise a negative x to a odd power, it's going to be negative. And since it was a positive on the outside, it becomes a negative. It will be a minus 7x squared, because when you square a negative x, it becomes a positive x squared. Minus 3x. Minus 9. How many sign changes do I have here?
1.
I do have a change. I have a 1 right here. Because I started positive, but then I went negative. So that tells me I have
1.
One.
Real negative zero.
1 real negative, real 0. And if I count down by 2s, I'm at negative 1, which is not possible.
Right?
Not possible.
I just messed
Alright?
up. I said 1 real negative zero. You didn't write it down.
Okay. Pretty simple, right?
Yeah.
Okay. We're gonna skip the next three. This is pretty straightforward, right?
Yeah.
The one thing I can really see tripping some of you guys up is you forgetting of when it comes to the negative x's, okay? And then you messing up your signs, so just be careful for that one. Don't try to be big and bad and skip this step of plugging in, okay? The conjugate root theorem basically tells you that if a polynomial p of x has a zero that is imaginary, a plus bi, this is a complex form for any imaginary number, then a minus bi, its conjugate, is also a zero, or solution of a polynomial. So you know, like when we solve functions, like x squared plus 1 equals 0, and I asked you to solve, right? How would I solve this?
-1.
Minus 1, and then square root, and so you would get what?
X plus minus I.
Plus or minus I. Realize it's not just I, it's also negative I. I and negative I, they're conjugates of each other. Conjugate basically means it's the positive version and it's the negative version, okay? Both of those are zeros of this particular problem. Not just positive I, but also negative I, because you take the plus or minus of it, okay? So that's what the conjugate root theorem is saying, is that not just the positive version, but also the negative version is a zero as well. So if you work it out and you figure out that 5 minus 2i is a root, root also means, say again, x, no, x intercepts. What's another word for x intercepts?
0.
So it's basically saying if 5 minus 2i is a 0 and x intercept, what other root do we also know? 5 plus 2i. It's conjugate. What about if I have 4 plus 3i? 4 minus 3i. Here's an extra one, let's call this 7.5. What if I tell you that you have a negative 5i as a root?
5I.
Then you know 5i is also a root that exists, okay? So it's conjugate. Imaginary numbers always come in pairs, okay? They always come in pairs. So it's never just the positive one, it's also the negative one as well. They always come in pairs. Questions? So, this part should be pretty simple enough. It's a nice little review before we get into the more complicated part. What are the zeros, roots, or x-intercepts of the following equations? How did you get that? Set both of those equal to 0. So you get x equals
-2.
and x equals
3.
Now realize that zeros, roots, and x-intercepts are always written how?
Points.
As points. So please, let's try to get into the habit of writing our solutions, our x-intercepts, our zeros, as points. Okay? Both 3 and -2 have a multiplicity of what?
1.
Very good. A nice review of the last unit. Okay? What about 10? How would I figure out the zeros, roots, or x-intercepts? Set them equal to 0. For the first one, how do I solve?
-1 divided by 3.
Subtract 1, divide by 3, so I'll have x equals, and you want to make sure you write that as a point. Over here, what would I get?
X equals 3 over 2.
I would have 3 over 2. Would it be positive and negative, or just positive?
Positive.
Just the positive, because when I take the square root of 0, it just gives me 0. And so then, yes, I'm only left with the 1. However,
It's got 2 multiplicities.
it has a multiplicity of 2 because of that right there. Okay. Wait, so for this one, we know we're going to have 3. Okay, and remember, we're going to write it as a point. But for this one, when we set it equal to 0, we're going to end up subtracting 1 and then and whenever we take the square root of both sides, it's always plus or minus, and the square root of a negative number is not real, it's imaginary, and in this case it's going to be I. And remember, imaginary, complex numbers always come in pairs. You have the positive I, and you also have the negative I. They always come together. Okay? Yes?
So you wouldn't put I square root
Well, I square root 1, what's the square root of 1? So you just have I times 1, which is just
in?
I. And of course, you would write these as points as well. Funny looking points for their points. Okay? Questions? Last little bit, we'll probably only be able to get through one example of this, but honestly, one is all you really need. Okay? It says write a polynomial equation for each given set of real and or complex roots. So now we're going from the zeros to actually get the equation. This is the part that we did in Algebra 2. Okay? Do more complex root stuff. Okay? So we are going to, given the roots 3 and 1 plus I, write the third degree polynomial equation. Well, if I have a third degree, that means I have how many zeros? I should have 3 possible zeros, but I only am given 2. What's the third one? 1 minus I. Remember, the complex numbers come in pairs. So if you have a 1 plus I as a 0, then 1 minus I is your second 0, or in this case, your third 0. Okay? So now we're going backwards. We're at the solution part here. We gotta work backwards. Okay? So if I have x equals 3, x equals 1 plus I, and x equals 1 minus I, y'all might want to write those. Okay? We got to go back a step. Okay, so what did we do to get a positive 3?
You had to have
Subtract. Add.
You had to add it over, so that means it came from a factor
X minus.
that was originally x minus 3 equals 0. Correct? Because you would have had to add it over. Here, same thing. You would have had a minus 1 plus I, or a variation of it. And over here, you would have had x minus 1 minus I. Okay? So basically, you are trying to write the factors here. So that way you can go backwards to write your polynomial equation. And from here, you multiply. Okay? Now, when you multiply, if you have any complex numbers, you always start with them first. Leave your real for later. Okay? Because when you multiply complex numbers, you should end up with a real polynomial. So when I multiply these together, I should get something that is very real. Okay? First thing I'm going to do, though, is I'm going to go ahead and distribute the negative to both of these. Okay? So this is going to be an x minus 1 minus I. Please make sure that you yourself can distinguish your i's from your 1's in your notes. And over here, I'm going to have x minus 1 plus I. And now I need to multiply these. Okay? Here we go. X times x, x times negative 1, and x times I. X I. On the ends, keep it moving. Okay? We're going to do this to every single term. So negative 1 times x, negative 1 times 1, negative 1, positive 1, and what's negative 1 times I?
Negative I squared.
Well, I'm doing negative 1 times I, so that's negative I. So let me fix that. It's not a plus and negative I, it's just going to be a negative I. Now for the last one, I'm kind of out of space, so I'm not going to do the curse. What's negative I times x? Negative xi. What's negative I times a negative 1? And what's negative I times I? Negative I squared.
That's like 1.
That is
0. It's 2.
Well, I squared, if you remember your powers of I from algebra 2, if you don't, you might wanna write these down. I squared is -1.
So it would be positive one.
So this would end up being a positive 1 right here. But the thing is that I squared is a -1. But because it's a negative right there, it does make it positive. I don't even wanna think that that's a positive one and then two.
So, would it be -1 or +1?
It would be a plus. Because when you plug that in, this will end up being a +1. So do not forget this from algebra 2, your powers of I. Okay? Question?
Wouldn't you combine like terms after?
And after this, you would combine like terms. And if you did this correctly, you should have no more imaginary pieces. Okay? Because if you look, xi and negative xi cancel out, don't they?
Yep.
Negative I and positive I cancel out, right?
Yep.
And we just found out that negative I squared is the same thing as,
X squared minus 2x plus 2.
that's, okay, y'all went ahead, I was just trying. A negative I squared, if I squared is -1, when you plug that in, you're gonna end up getting a +1. So when you combine your like terms, you have an x squared minus 2x
Plus 2.
plus 2. And no more imaginary part.
Yeah, more fun.
And now you multiply that by x minus 3. And that's just some more distributive property, okay? So to finish this up, that's x to the third minus 2x squared plus 2x. Then a minus 3x squared plus 6x minus 6. Combine like terms, you get an x to the third minus 5x squared plus 8x minus 6. And there's a polynomial that's to the third degree.
Oh, you get it with the